Good day everyone. Welcome back for another Excel program video tutorial on reinforced concrete. This day we will focus on the program designing in axially loaded tide columns and spiral columns using NSCP code 2001 and 2010 or 2015. First, in this sheet of Excel, we can see that we have two programs, the tide column and the spiral column. First is we will utilize designing or solving for problems with regards to axially loaded tide columns using NSCP code 2001 and 2010 or 2015. Without any further ado, let's proceed with our example. Our example in here is that design a square tide column to support an axially loaded of 505 kN and axial live load of 795 kN. Assume that our FC prime is 27.6 megapascal, our Fy is 414 megapascal, and we will use a 28 millimeter main bars and 10 millimeter diameter of ties. In this program, we have the two sections, the input areas here and the output areas are being placed in here. Our input areas will be the given data of our problems, while our output will be the solution of designing. In this section, we will input the dead load, the live load, the FC prime, the Fy, the diameter of main bars, and the diameter of tide bars, and also the draw to be used, or the what is that? Oh, that is being used. First is let's input the dead load, which is the dead load we have in the given problem is 575 kilonewton. Then the live load we have 195 kilonewton. The FC prime we have 27.6. The Fy 414 megapascal. The diameter of main bars is 28 mm. Then the tide bars is 10 mm. Then we have 0.02. Then after inputting all the data, given data, we can easily or we can come up with the output. The difference of 2001 and 2010-2015 is that in 2001, the PU actual, we will utilize a formula of 1.4 dead load plus 1.7 live load, while in 2010-2015 we will utilize a 1.2 dead load, a PU of 1.2 dead load rather, plus 1.6 live load. And also the difference is that their fee being used is in 2001 we have 0.7 and in 2010 we have 0.65. The rest of the formula, as you can imagine and or you can recall from the topic on designing a square tide column, everything are the same except for the PU or the actual force and the fee. After inputting all the data, we will automatically determine the AG, the column dimension, the number of bars, the spacing, and also the same with 2010-2015 NSCP code. So in choosing for the spacing for lateral ties, we will use the smallest value of spacing, or the smallest value of spacing on lateral ties. So first spacing is 16 multiplied with the diameter of main bars, and another is 48 multiplied with diameter of ties. Then also the least common dimension of our solution on 2001 NSCP code is 351. So choosing for the three, we can conclude that for 2001 NSCP code, we will use a 10 mm diameter lateral ties spaced at 351 mm diameter. So this would be the solution, wherein it is on the spacing of lateral ties, it is the smallest among them. Then also in here, so 448, 480, and the least common dimension is 348, which is being solved from the 2010 and 2015 NSCP code of an answer of 348. So since it is 348 is the least space among the lateral ties, so we can conclude that for 2010 or 2015 NSCP code, we will use a 10 mm diameter lateral ties spaced at 348 mm. So this would be the solution for 2001 NSCP code, or the answer after we will input all the data from the given example, and then for 2010 also we will come up with 348. So let's proceed to another sheet of Excel program, which is a program for the design of axially loaded spiral column using NSCP code 2001 and 2010 or 2015. So without any further ado, we will proceed with our example. So our example would be design a round spiral column to support an axial dead load of 800 kilonewton and live load of 1,350 kilonewton. Assume that 2% longitudinal steel is desired. In FC prime, we will use 27.6 megapascal and Fy of 414 megapascal. And we will also use 25 mm main reinforcement and 10 mm diameter spiral with 30 millimeter steel covering. So same with our tied columns, this data, this section in here, we're in the input section, we will input everything, every units and every given dimensions on the example. So for the dead load, we have 800 kilonewton, the live load 1350 kilonewton, the FC prime we have 27.6 megapascal, the diameter of main bars we have 25 millimeter, the diameter of spiral bars we have 10, and for steel coverings we have 30, and for the longitudinal steel, a desired output would be 0.02 or 2%. So after inputting all the data, we will come up with the output. So this section in here is the solution for 2001 NSCP code, and this section we have the 2010 or 2015 NSCP code solution. So same with the tied columns, our PU or the force actual or the PU actual are different. Wherein in PU actual of 2001, we will utilize a formula of 1.4 dead load plus 1.7 live load, while on 2010 we have 1.2 dead load plus 1.6 live load. So when it comes to phi being used on solving for the round spiral column or axially loaded spiral column, their phi for both NSCP code are the same, wherein they have a 0.75 values. So same with the tide columns, after inputting all the data, we would come up with an answer for AG, for column dimensions, for number of bars, for the DC, the AC, the AG, the ES, the P minimum. So after that, we would also come up with the spacing, and for the S clear, it's only we will use a formula of S clear is equals to S minus diameter of spiral bars, which is our answer would be 69 mm. So for 2010, same with 2001. So the spacing we attain is that we have 78 mm, and for S clear we have 68 mm. So 78 deducted by a diameter of spiral bars, we have 68 mm. So and also I put this okay. Why? Because on for the what is this? On solving for the design of round spiral columns, we have to attain wait a we will be attaining a code wherein 25 must be the S clear must be greater than or equal to 25 and less than or equal to 75 mm. So 69 is less than 75 and 68 is less than 75. So that's why it is okay to use a spacing of 69 and 68. And also, we can conclude that for 2001 NSCP code, we will use a 10 mm diameter of spiral bars at space at 69 mm. And for 2015, or 2010 NCP code, we will use a 10 mm diameter of spiral bars, space at 69 mm OC. So that would be all. Thank you, and see you for another video tutorial next time.